Welcome back. Today we're going to be talking about atoms, which are one of the most important things to know about in science. Because without atoms, we wouldn't be here, and really neither would anything else. So, what is an atom anyway? And I've talked about them a lot, but an atom is actually the smallest particle of an element. So, if we look at an atom as kind of the smallest particle of matter, that's one thing. But if we look at it as it is the smallest particle of an element, all matter can be divided into pure substances and non-pure substances. And the pure substances are elements and compounds. Elements are the most pure because an element is just a substance that's all one kind of atom. And so these atoms will make up a compound. So if you had something like, say, copper, which is Cu, if you had a block of copper, then every single atom in that whole block would be a copper atom. And it wouldn't be anything else, because that is how we define an atom and how we define an element. So basically, if you look at the periodic table, you can choose any element, for instance, boron or carbon, and it's made of carbon atoms or boron atoms. Now, we're going to talk now about how to draw a reasonably accurate atom. We're going to simplify this since, this is just 6th grade. We're not going to do the high school version or anything, but basically atoms have 3 parts. Protons are positive particles, neutrons are neutral particles, and electrons are negative particles. And so what we do is we look at our little box on the periodic table again, and it's got all the information we need to draw an atom of that element. Okay, so carbon is number 6, and it has an atomic weight of 12.011. That number 6 tells us the number of protons it has. So the atomic number is always the number of protons that an atom has. The number of electrons is going to equal the number of protons. So you look at the atomic number for that too. And then neutrons can sometimes be a little different. So neutrons don't do anything. They just add weight. But they weigh the same as a proton. Electrons, on the other hand, are teensy weeny compared to the other ones. So, for instance, if a proton is 1, then the electron would be 0.0001 compared to that weight of the proton. So, anyway, before you get too confused, neutrons, the way you figure out how many neutrons there are is you take the atomic mass and subtract the atomic number. So the atomic mass, you just round it to the nearest whole number. And what you're looking for is the atomic mass tells us the number of total particles in the atom. And then you round it to the nearest whole number because the electrons are so small they don't matter. And then you're going to do atomic mass minus atomic number, and that gives you the number of neutrons. So let's draw a carbon atom, shall we? So if we were going to start with protons, we know from looking at our box that a carbon atom has 6 protons. So I'll just draw 6 little bubbles. I think they look kind of like grapes. And the middle part of the atom is called the nucleus, and that's where all the protons and neutrons live. And the way I remember that protons have a positive charge is I just say my P's really loud. So protons are positive, represented by a plus sign. Neutrons are neutral. They have no charge. Oh, but we haven't figured out our number of neutrons yet. So what we have to do is go with 12, because we rounded this one to the nearest whole number, minus the atomic number, which is 6. And so that'll give us 6 neutrons. Okay, so in this case, the number of protons and neutrons are the same. So then we'll just do 6 neutrons. All right, so now those protons and neutrons are happy together in the nucleus, and the electrons now are zipping around the outside. We're going to have the same number of electrons as protons, because otherwise that atom will have a charge and it'll go around zapping everything. And we want it to be neutral. So we just put those electrons around the outside. And this is how we get that picture that you're always seeing of atoms, because those electrons zip around the nucleus in specific places and on specific pathways, or more generally in certain levels. But that's why you draw an atom the way that you do. And thank you for coming and joining me, and let me know if you have any questions. Thanks.